In this video, I'm going to show you how to solve for x, mainly using logs, and in one case where you don't have to use a log. Also, this last video, this last question is a little bit higher level, so if you don't get everything in this one, that's completely fine, but it's the using ln and using e that I really want you to see here. Okay, so for that first one, you always want to check and see if you could rewrite one of the numbers using the same base as the other one. So for example, 2x squared could stay where it is, but we could rewrite that 8 as 2 to the third, right? Because 2 times 2 times 2 is 8. So it's 2 to the third to the x power. All I did was replace the number 8, rewrite the number 8 as 2 to the third. Now, a power to a power means that you multiply the exponents. So that's 2 to the 3x. Now, the only way these two things could be equal is if x, sorry, this is the x squared, is if x squared is equal to 3x. So we could just look at it like that. Now, this is a quadratic, so let's get it equaling 0. So x squared, I'm going to minus 3x on both sides, is equal to 0. Let's factor it. I'm factoring out an x. So basically I'm dividing everything by x here. So you get x minus 3 equals 0. And well, if these two things are being multiplied to give us 0, x itself, so this x is equal to 0, or the other thing over here, x minus 3 is equal to 0, which in this case would mean x is equal to 3, right? Just add 3 on both sides. So you have two solutions that could satisfy this equation. Let's do b. So b is 3 to the 1 minus 2x is equal to 5x. Now notice these numbers are relatively prime, so you cannot rewrite one as, as a power of the other one. So this is where logs come in handy, and I'm going to use a natural log in order to solve this. So all we're doing is we're taking the natural log. And why am I using the natural log? No other reason than it saves me from writing log with like a number as a base or something, right? So that's really the only reason I'm using ln. It just helps with time, is equal to the ln of 5 to the x. All right, so just take the ln of both sides. Now the exponent, you could put in the front. This is 1 minus 2x, put that in parentheses, times the ln of 3. And that's equal to x times the ln of 5. All I did was I took that exponent and I put it in the front. Because you can do that when you have logs. Take the exponent and put it in front. Let's distribute this ln of 3 into each of those, because I need this x. I need it out of there. So ln of 3 times 1 is ln of 3. ln of 3 times 2x, well, there's a minus there, so let's put a minus, is 2x ln of 3. And this side is nothing to do, so we just leave that as it is. Now I want my x's together, so I'm going to take this and I'm going to subtract it on both sides. Minus ln of 3 on both sides, minus ln of 3. Now I can't just subtract those. This x is connected to that ln of 5 by a multiplication. And even then I just can't subtract them like that. So I want this x on that side. So I have to really minus this entire thing on both sides of this equation. So just going to rewrite it now. Negative 2x ln of 3 minus x ln of 5. All right, if it helps, I'll put this in parentheses so you can just kind of see. Maybe might clear up something for you there. Is equal, well, this is canceled, this whole thing, right? Even though the line only goes through that, is equal to negative ln of 3. I kind of went through that quickly. I hope you guys get the gist of it. The goal is to get an x by itself, so I have to factor out the x That's the only reason I put them together. So let's factor out that x. So you get negative 2 ln of 3 minus ln of 5 is equal to negative ln of 3. When that x by itself, so let's just divide both sides by negative 2 ln of 3 minus ln of 5. And I'm doing that on both sides. So negative 2 ln of 3 minus ln of 5. And this entire thing divides out. And we remember this as our answer. And notice, since every aspect of it has a negative, I can kind of factor out that negative one and just they cancel out. So remember just the positive version of that. Ln of 3 over 2 ln of 3 plus ln of 5. Ooh, you can barely see it there, but you get the gist. Okay, let's do C on this side now. C, log base 3 of that. Okay, so immediately I know that, well, you need to notice log with the base b of x, if that's equal to a. Now, the way you look at a logarithm is that the base to this power is equal to the thing inside the parentheses here. So that's equal to x. So using this, I'm going to rewrite this as 3, because that's the base, right? The base goes here, 3 to the what? To the 2, right? The thing after the equal sign is really the exponent, is equal to the thing inside the parentheses. So it's 2x minus 4. Okay. So that's 9 is equal to 2x minus 4. We want the x by itself, so add 4 on both sides. You get 2x is equal to 13. Divide by 2 on both sides. X is equal to 13 over 2. Okay. And finally, let's do D. I may not finish E in this video, but let's do D. D. Okay, so this plus, when you're adding logs, you could rewrite them as a multiplication. So this is log base 3, and we're just multiplying the things on the inside. So this is x plus 12 times x plus 4, and all of that is equal to 2. Now, we're going to do it in the same way. 3 to the second power is equal to that thing. So 3 to the second power is equal to, I'm just going to multiply that right out. X times x is x squared. 12 times 4 is 48. 12x plus 4x is 16x. Okay, so we get 9 is equal to this thing over here. Now, it's a quadratic, so I'm going to solve this by making it equal to 0. So I'm going to minus 9 on both sides. So we get 0, this cancels, is equal to x squared plus 16x. And this is plus, is that 39? Is that what that is? I'm assuming that's right. Now, I know, just because I did it in advance, when I factor this, I'm actually going to get x. I don't remember now. Plus 13 and x plus 3. Let's just check it. The two numbers need to multiply to give you 39. 13 times 3 is 39. They need to add to give you 16. Yep, so that's right. So x is equal to negative 13 and x is equal to negative 3. Now always do this check. You cannot take the log of a negative number. So if x was negative 13, I would have a negative 1 here because negative 13 plus 12 is negative 1. So we have to reject this solution. Let's check the negative 3. That's positive. Negative 3 plus 4 is positive 1, so that's positive. So this one's good. So x is equal to 3. I don't want to do E in this video, but what I'll do is I'll do E in a separate video, and I'll link it in the description below. Okay.